Good morning. My name is Walker Moore. Today, I'll be giving one portion of a presentation entitled Sustainability in Construction. I've collaborated with Chase Petty, Jay Memon, and Joshua Hardaway on this assignment. Now, when we're talking about sustainability, it's important that we give an accurate definition of sustainability. Sustainability is about meeting our needs today without compromising the ability of future generations to meet their own needs. We're going to go into a little bit greater depth on sustainability. We're going to introduce the three pillars of sustainability. We're going to talk about how sustainability differs in construction when compared to other products. And we're going to use a little bit of a case study to illustrate some of these points. Now, the three pillars of sustainability are as follows. They are the social pillar, the environmental pillar, and the economic pillar. All three of these pillars work in tandem in order for sustainability to actually occur. If any one of these three pillars is neglected, the product that's being produced is not truly sustainable. I'll be discussing environmental concerns related to sustainability. Chase will be discussing social concerns when related to sustainability, and Jay will be talking about economic issues when related to sustainability. Now we're going to get into why construction is a little bit different when we're talking about sustainable initiatives. It's different because of a building's longevity, the building's complexity, and the scale of the building. Buildings are oftentimes rated for at least 25 years. Normally, they'll be a little bit higher, and in some cases up to 100 to 100 plus years. What we're talking about here is having an incredible impact years from now. The construction industry isn't a short-sighted product. Our products have an impact for decades. It adds a layer of complexity when introducing sustainable initiatives. Next, we're going to talk about complexity. And when we're talking about complexity in these terms, what we're really talking about is the number of individuals that are involved in seeing a project finished. Hundreds, if not thousands, of individuals in the construction and pre-construction phases. Not to mention the occupants of the building after. We have to consider their needs and make sure that we are meeting their needs for years to come. And then scale. Buildings are some of the largest products that we produce. Aside from aircraft carriers and commercial seaworthy vessels, buildings really are some of the biggest products that we make. Now we're going to move on to our case study. We have two buildings that we're going to be discussing here. On the left, you'll see an image of the Nakagan Capsule Tower. On the right, you'll see an image of Habitat 67. I also have two models here in the room with me that I'll be making reference to. This is the Nakagan Capsule Tower, a massing model of it. And here is Habitat 67, small massing model of it. Now, when I discuss these structures, I'm going to be speaking about them in environmental terms as it relates to sustainability. My teammates will also discuss these models in terms of economic or social sustainability. Now we'll move on to my research findings. Again, I'm focused on environmental sustainability. I cannot stress how important it is that we not conflate sustainability strictly with environmentalism. Sustainability is composed of three pillars. Environmental concerns, that's only one pillar. We cannot neglect social and economic sustainable initiatives either. But without further ado, we'll move into environmental sustainability. I'm going to discuss a number of issues that are concerns as far as environmental sustainability is concerned, and address some of the ways that we can deal with these issues. Now, first, we're going to be talking about hydrology. Hydrology is the study of natural water processes, the way that water moves. Over hundreds of thousands of years, creeks, rivers, lakes have developed naturally as a response to dealing with watershed. When the ground becomes too saturated, the water has to go somewhere, so it finds its way into creeks, rivers, and eventually to the ocean. Now, when we introduce buildings, especially in urban environments, the pavement and the roof lines repel that water and do not allow the ground that is supposed to soak that water up to soak the water up. So what we wind up having is higher peak floods when heavy rains come our way. This is most noticeable, especially in urban environments. Hurricane Harvey, for instance, devastated the Houston area. There have been studies conducted in China, and they deal with heavy monsoons in this region of China. They were focused on the use of permeable pavement in construction. Permeable pavement allows for water to penetrate through the pavement and get to the ground where it can eventually recharge the groundwater levels, putting less strain on these natural water bodies that would normally hold the water. This can reduce flooding by up to 60%. It's huge. Imagine if Hurricane Harvey had been 60% less high in its flood peaks. A lot of money would have been saved. You can also make use of retention ponds. This is not new necessarily, but it's something that you're saying a little bit more commonly. All the water on a site will move in towards that retention pond. Additionally, green roofs can be used. Green roofs have soil and flora on top of the structure itself, which soaks up this water, feeds the plants. It's great. Additionally, green roofs allow for a better connection with nature. This increases productivity. It's twofold. It does a couple of things. I'll speak about it a little bit more in the future. Now we're going to talk about building emissions, or reducing emissions in buildings. Whenever you have a conversation about environmentalism, emissions almost always come up. The building industry is responsible for 40% of total emissions worldwide. Now, of that 40%, only 10 to 20% of that 40% come from the construction industry. To put it in more simple terms, what that means is that in total, 4 to 8% of all emissions are directly accounted for in pre-construction and construction phases. That's 4 to 8% of all emissions worldwide are pre-construction and construction. That means that 32 to 36% of all emissions occur over the building's use cycle. We have 3 cycles here. We have the construction and pre-construction phases, and then we have use. Now, if you remember, I said that most buildings that are built today are rated for at least 25 years, up to 100 years. It means that what we as contractors do today has an enormous impact for decades to come. Reducing the amount of energy that needs to be consumed and thereby reducing emissions is paramount as far as actually achieving sustainable results for the environment. And we can do that by using Energy Star appliances and making efficient use of our resources, orienting our buildings in such a way that natural light helps to heat the building in the winter and avoid overheating in the summer. Making good decisions as far as our HVAC design is paramount. Solid design really helps us to reduce our energy consumption and reduce emissions. Now we're going to talk about land clearing. Land clearing has to do with removing the natural flora that the site occupies. Now, when we do that, it also prevents the local fauna that call that place home, that use it as their natural habitat, they have to relocate. So land clearing also increases erosion. By removing the root systems that hold the soil in place, when heavy rainwaters come, it washes that soil away. This erosion then can enter into our natural water systems and help to clog sewers, help to build up the bottom of creek beds, lake beds, things like that. We don't want that to happen because that also contributes to increasing peak floods, and we need to build more infrastructure in order to handle this, such as our sewer systems. So what is encouraged is to leave as many trees as possible on the site when new construction commences. Another way to address issues concerning land clearing, specifically on biodiversity, is to reintroduce plants that are native to the area. The plants that ideally were initially removed, the exact same species of plant should be relocated when landscaping is occurring. They should be put back in place. This allows the fauna that was displaced to hopefully find a new habitat. But now we're going to move on to light pollution. Light pollution is an interesting topic. I found an article that discussed how artificial light, photons from artificial light, have in some way been directly related to the development of tumors. But that seems a little far-fetched. I'll move on to some other more direct impacts on the environment that we can observe. The migratory birds are very much impacted by artificial light in the night sky. A number of nocturnal animals are as well. This artificial light prevents them from engaging in cyclical processes that they really rely on. One way to combat this light pollution is to make sure that streetlights, for instance, have a cover over the top of the light that directs all of the light produced directly down towards the street, not allowing much of it to escape to the sides and allowing none of it to escape upward. Turning off lights in commercial structures at night. You drive through a city, you'll see a commercial structure that has all of its lights on when no one is really in the building. Making sure that those lights are turned off systematically every night will help to prevent the amount of artificial light that we and animals are exposed to. Now we'll move on to the Earth's albedo. The Earth's albedo, the albedo effect, has to do with when light hits the surface of the Earth from the sun, quite a large amount of the heat is bounced back into the atmosphere. Instead, with the introduction of pavement and dark colored roofs, a lot of that heat is absorbed by these features, which increases the heat of the area around that structure. This is most noticeable in urban settings and contributes to what is known as the urban heat island effect. In New York City, green roofs and white roofs, as opposed to dark colored roofs, traditional roofing systems, those green and white roofs help to reduce the heat in the area by 2 degrees Celsius. It's 2 degrees cooler just through the use of green and white roofs. By using materials that work to reflect that heat as opposed to absorb it, we can help reduce the urban heat island effect. Now we're going to move on to sound pollution. Sound pollution can be a little bit devastating. Sound pollution can contribute to hearing loss. It can decrease productivity. If you've ever been on and around a job site, you know what I'm talking about. Structures alongside new up-and-coming construction projects, those employees within that commercial setting might also be negatively impacted. Again, their productivity might take a hit. In response to this, a number of city ordinances regulate how many decibels of sound can be produced off of the job site. This helps protect some workers as well that are on the site from engaging in hearing loss. Of course, using hearing protection is paramount, but it also helps to prevent passersby, individuals that are commuting around the job site from being exposed to such ridiculous noise levels. Now we're going to move on to the Nakagan and Habitat 67 and use these as a study. If you look at the Nakagan capsule tower, you'll notice that there isn't really much in the way of greenery. The only thing that Nakagan really has going for it that it tries to incorporate nature into its design are the large windows. This is just a massing model, so there are no windows visible, but each one of these capsules has a large window that allows natural light in. This is a good thing, but again, not a lot of attunement with nature, especially as opposed to Habitat 67. You can probably see just a sheer amount of greenery. They made extensive use of green gardens on the surface of the structure, personal green walkways, things of that nature really help increase productivity and lead to better quality of life, better satisfaction rates. Now we'll move on to why sustainability matters and why is it a concern for the construction industry specifically. Now, as we mentioned earlier, emissions due to the construction industry account for 40% of total emissions. 10 to 20% of that 40% of these emissions are in our construction phases. So there's a lot of emissions coming out of our industry specifically. Now let's talk a little bit more statistically about our industry. We're active globally. The construction industry is booming everywhere and in every country. $531 billion in annual revenue are raised in the US alone. And 1.7 million employees are employed in the construction industry in the US. Huge sector. Now, why is that so important? Well, we might expect that some governments are taking notice of emissions and they're starting to make greater moves towards sustainability. For instance, Germany has moved for climate neutrality by the year 2050. The UK will reduce emissions to 80% by the year 2050. That's huge. That's an enormous reduction. In order for them to achieve these results, it's very likely that they're going to start taking a look at the construction industry and seeing what they can do to regulate emission levels. We can probably expect some form of regulation in the future. Now, public opinion is also starting to weigh in on this. There's a greater demand for sustainable products. It's increasing. Now, the private sector is responding to this. For instance, Amazon has pledged that by 2024, 80% of its energy use will be renewable. That's a huge commitment to make. In short, understanding sustainability and being able to speak this language is an asset. It will help you as an individual in your construction career survive. At a certain point, I think that we're going to hit a spell where it can't be helped but regulation come in. If we are not able to adapt to this, we will not be as marketable. Our companies might not be as marketable. And as a result, we might find ourselves out of a job. Here are some references related to the topics that we discussed today. Some of these references are also used by my peers. Well, thank you for your time. I hope this has been informative and I hope that you have a great day.